So for the second part of Section 2 lesson, we're looking at some things that really all came up in the Part 1 video, but you're getting some bonus examples here of some examples that will help. So if we were to take a look at tossing a die, and we said, what's the probability that the number showing on top is either prime or composite? Composite just means it's not prime. We'll take a look. It's either, these are the prime numbers, these are the composite numbers, and then one is considered neither prime nor composite, so that would be the other number. But if you talk about a number being prime or composite, well, notice there's no overlap there. You can't have a number that's both prime and composite, so those are what we call mutually exclusive events. They have no overlap. There is nothing in common, and we looked at that on an example in the previous video. But so if we just said, what's the probability of getting a number like that? Well, we just add those cases together. It's either prime or composite. If we add those 5 numbers together, 5 out of the 6 values fit that description. So we looked at the formula packet for this in our last video. So if things are mutually exclusive, you just add them together. This does not exist because they have nothing in common. We would say A and B is 0 for a case like that. So that's what you're seeing right here. So A and B is 0 if they have nothing in common. There's no overlap. So when they're mutually exclusive, you simply use that formula and you add your 2 cases together. Keep in mind this represents the word or, and this represents the word and. So this is saying the probability of A and B happening would be 0, simply because you can't have both if they're mutually exclusive. And this is A or B, where we just add the 2 cases together. So in this one here, here's a case where they are not mutually exclusive. There's something else going on here. So if we said the probability that the number showing is either prime or odd, well, in circle M, you're seeing all the prime numbers from 1 to 6. So 2, 3, and 5 are the prime numbers. Please note that 1 is not considered a prime number. We consider the first prime number to be 2. 2 is also the only even prime number. There should be a 4 out here as well. So the numbers 4 and 6 are neither prime nor odd. So those would be both out here in the universal set, but not within the circles. So in this one, if we said prime or odd, we'll notice that there are 2 numbers here that are both prime and odd, and so that's something we have to take into account. We can't simply add the numbers. There's a little more going on to this. So one way to do it is with a Venn diagram, and you could get, if you had a good Venn diagram, you don't need a formula. If we say prime or odd, I simply look at all the numbers in the circles and I add them together. There are 4 numbers out of the 6 that are prime or odd. So I don't need a formula to figure that out if I had a Venn diagram like this to look at. But if you don't have a Venn diagram, or if you just want to use the formula, well, here's how the formula would go. So I'm looking at this one right here, because remember, these have something in common. There are numbers that are both prime and odd. There are 2 of those. So if we're going to use this formula, we'd say, well, the probability that it's prime is 3 out of 6. The probability that it's odd is also 3 out of 6. So we're going to add those up, but we're going to subtract out the ones that are both prime and odd at the same time. And there are 2 of those, so minus 2 out of 6. And so that's what you're seeing going on here with the formula. That's this layout. So prime plus odd minus prime and odd. So there's that formula. Just so some further examples here. If we said, what's the probability that you pick a card from a deck and it's either an ace or a king? Well, keep in mind, those are mutually exclusive. I don't have any cards that are both an ace and a king at the same time. So I just add those 2 events together. So we just say it's 4 out of 52 plus 4 out of 52, which is 8 out of 52. But if you compare that to this one, these are not mutually exclusive because it says the probability that it's either ace or red. Well, there are 2 cards in the deck that are both an ace and a red card. And so there's a little overlap going on here, so there is an extra part of that formula that we have to take into account. Again, you could do this without a Venn diagram, or I'm sorry, without a formula. If I have a Venn diagram, in an OR scenario, I just add these 3 numbers together. So I would just say, well, if I add those up, 28 out of the 52 cards are either an ace or a red, and so that would be my answer, 28 out of 52. The other way to do it is with the formula. So if I don't have the Venn diagram to work with, then I can go to the formula and I do aces, so there's 4 aces, plus 26 red, minus the 2 cards that are both ace and red, and I still get the same answer of 28 out of 52. And then for the very last one that you see here, this is just pure formula work. And again, if you did a good Venn diagram for this, you can really get away with some things here without a formula. But this is just a direct plug into the formula if we want to go that route. So I'm just filling into this formula that you see right here. So we just said, well, here's the A or B is the 0.88. So that's going in for A or B. Right here, we were looking for the probability of A. They told us that B is 0.76 minus A and B, which is 0.36. And if we just solve for A, this is what we come away with.